So
I mean, like May.
I don't know the answer to that question. I know right now there's absolutely no allowance to go into the school buildings because they've been cleaned and locked off where you can't get in there to spread coronavirus. So right now that's a hard no. But at some point, Fred, they will give you this plan of how to do band instruments and string instruments. But right now I don't know what it is.
Mr. P.
Yep.
Betty said that she that was her little brother. He had I mean that's her, but she changed her name for her little brother's Zoom meeting.
Okay.
Yeah.
Thank you, Lincoln.
No problem.
There it is. Yeah, I see it. And I figured it was legit, but I can't take a chance on getting somebody that's not supposed to be there is the problem. All right, so let's go. Anybody else have a question about that stuff like we just talked about? If you do, just say it out. Anybody? Josephine, you unmuted. Are you going to ask a question?
Yeah.
No. Okay.
We'll still be getting our yearbooks.
Say again, Fred.
We'll still be getting our yearbooks.
Yes, you will. I don't know how. They'll probably be mailed to your house. No, you will get it, but I think it will be mailed to your actual house. Because, and here's why I think that, Fred, because in lots of school systems, they literally don't get the yearbook at school. It gets mailed to the kids in the summer because they don't finish it until the end of the year. But we always get ours finished in like February so it can be printed and be to school in May. So yeah, you will get it. And you all paid to go on that field trip to Words and Music. That didn't get to happen. And so next year, somehow that will get dealt with, but I don't know what the answer to that is either. So eventually you'll get back your money for that. Any other questions? Anybody? Okay. So yesterday, quick review, we talked about, so by the way, the reason I was a couple minutes late is because the Pear Deck I had to relaunch it a bunch of times, and we had a 6th grade team meeting that went up and I had to literally leave it like a minute before 11. So my point to say is I hope these slides are in the correct order because I was trying to check them while the meeting was going on to make sure. Okay, so yesterday we talked about rectangular prisms. Could someone unmute and tell me what is the difference in a rectangular prism and a cube? You don't need to write it. Go ahead.
Mr. P. So pretty much the difference is a square, a cube is a rectangular prism, but a rectangular prism is not a cube.
Correct. That's right. So
I have a question.
Yes.
So with a rectangular prism, is the square still the base or is the rectangle?
So in a rectangular prism, the rectangle would be the base. So whatever the prism is called, that's what it's going by because of its base.
Okay.
So on a cube, you can't tell which is the base because they're all the same, right? That's the only difference. But a cube is still a rectangular prism. It's just a rectangular prism that happened to have a base that's a square. Another real quick characteristic about prisms in general, you're only calling something a prism if it has a polygon base. So that means it's a triangle or quadrilateral or a rectangle or a trapezoid or whatever. It has a matching top that matches the base, right? And then it has rectangle sides all the way around. That's the definition of a prism. Could someone tell me why all the side panels are rectangles on prisms? Why would all the side panels be rectangles on a prism? Now, not the base and the top. The base and the top could be a triangle or a trapezoid or a parallelogram or a hexagon or whatever. But why would all of these walls around it always be rectangles?
It's the only shape that can connect all the joints properly.
That's exactly right. You couldn't have said it any better. It's the only shape that would connect that top and bottom and make it to be a prism. That's exactly right. Okay, so yes. So even though it's got a rectangle for a base, it's still going to have rectangle walls. But if it's got a triangle for a base, it's still going to have rectangle walls around it. Okay. So again, this was just showing you that there are 6 different ways that a net could be made from a rectangular prism. This particular net series is about a cube, right? So they're just different ones. That's just a review from yesterday. All right. So quick review. Could someone tell me what is going on this slide from yesterday?
Like how to find the area?
Yeah, please. Surface area. Yeah.
Okay. So you want me to find the answer to it?
Just tell us what's on the screen there. Just tell us what all that is. I don't
Okay,
need
so
the
on the screen, the 2 faces, T and B means top and bottom,
Yep.
which is times length. So that would be, so you would have to do that times 2, the answer.
Yep. Mm-hmm.
So that would be 60. And then F and B mean front and back,
Okay.
which is 10 times 4, which is 40, and you have to multiply that times 2
Yep.
to get 80. And then side to side is 4 times 3, so you would get 12, and then 12 times 2 is 144.
Yeah, with those sides. I wish I had a way to color code these arrows, but I don't know how to do that on Zoom. So that's exactly right. So if I said 10 times 3 is 30, 2 of them, because there's 2 of those kind of faces, 2 of those shapes. And by the way, you call all the sides and the top and bottom, they're all called faces. And then you've got 2 of these front backs.
Mr. P,
Yes.
I think you can color code the arrows.
You do?
Just change the color of your annotations.
Yeah.
Look there. Yeah, sure can. Yep, you can. Thank you, Jayla. All right, so the front and back would be these. And then the 2 sides would be here. Yeah, thank you, Jayla. All right, so what I was going to say was, think of it like a cereal box. You got the top and the bottom, you got the 2 side panels, and then you got the main front and the main back, right? Yeah, that's correct. All right, so let me clear that out and let's move to the next page. You didn't need to write anything there. All right, so on this now, I do want you to come up with the surface area for this, please. If you'll go ahead and give me the surface area of this rectangular prism, please. Thank you, Jayla, for that. I think we just talked about this one yesterday. That's where we stopped. So Courtney, will you in just a minute tell us about what the surface area is of the front and the back part? And then Fallon, will you tell us about the 2 side parts in a few minutes? And then Fred, will you tell us about the top and bottom?
Did that play?
Sorry.
All right, do I have the right measurements on the screen? Okay, let's see, was Courtney going to talk about the first one? Maybe she can't hear, but so would it be 7.5 times 2.5 to get that rectangle for the front and back? So 7.5 and 2. I just changed the fractions to decimals, yeah. And then I'd have two of those. Could somebody, Courtney's not on, could somebody tell me what would be the total of the front and back together? Is it 1875 times 2?
It's 37.5.
The whole thing? Right, two of
Yes.
those. 37.5? Betty? Is that right? All right. Could Fallon, can you tell us about the sides?
Yeah, it's 4 times 2.5.
Okay.
10.
And
And
that's
then 10 times 2 equals 20.
perfect. Great. Thank you. And then Fred, do you mind to tell us about the top and bottom?
7.5 times 4 is 30, and then times 2 is 60.
Okay. So there you go. So then you add that up and you get 80 plus 37. So that'd be 127 and a half total. Is that right? So the surface area, if I just mentally did that right, would be 127.5. Is that right?
Yeah.
Okay. Square inches in total. All right.
No.
Okay.
No, you wouldn't. You wouldn't have 5. Oh, I don't know where you got that from.
Yeah, you're right. A 7 there. Yep. Thank you. All right. So yeah, that would be how you would get the surface area. Now, I don't know, I didn't check the arithmetic, but that's the process, right? Okay. So now let's look at this. And if you will, on your screen, is this a draw or a type on yours?
It's
A
draw.
draw.
This is a draw. Okay. This is a draw. Will you color code the two top, the top and bottom part? And will you color code differently the sides and then the back, the front back?
Can you say that again?
Yeah. Color code the matching top and bottom, the matching sides, and the matching front and back.
Okay.
The parallel sides. And while you're doing parallel faces, while you're doing that, I'm going to type up here the numbers to talk about those together. Let me let Izzy in just a second. Okay, let me look at my phone and see what y'all got here. All right, good job. You all are matching those. Now, did you notice that you could argue that, well, these are the sides, and then, well, this is the top and bottom, well, this is the front and back. But it's about getting the two matching sets together, right? So now that I know that I can do different arrows, let's do that. Okay, so this goes with that, correct? All right, and this goes with this, and this one goes with that one, right? Everybody agree with the color code? Now, I just pretended to say that the blues were the top and bottom, and that the black was the front and back, and then the other two were the sides. Could I reverse that and change it around? Sure. But those are the ones that match each other. And it's about, when you're doing surface area, that's what you're looking for, is those matching parts. Now, is there anything to say you couldn't just literally do each separate face and get its area and just add all those 6 up? Yeah. But it would be a lot easier just to get the ones that are the same or congruent and put those together. So y'all got some mad coloring skills here. I like to see your skills there. Okay, so here's the next one. All right, on this, if you will, let's look at what is the total surface area. So let's work on this one together, okay? So let's start with the quote base and top. So I'm going to think the base and topper is that the dotted line one. Okay, so we can say that's the base and top. So I'm going to say top bottom is, and it's 7.4 times 5. Is that right? All right. And then the two sides, could somebody volunteer to tell me what the side measures are? I thought I heard Lincoln's voice. Are you there, Lincoln? What are the two
Mr.
sides?
P, it would be, wouldn't it be 3.1 times 5?
Okay, yep. 3.1 times 5. Perfect. All right. And what would then be the other two faces we didn't get, which would be our front and back? Now, again, there's no law saying that's the front and the back. It's just a way to reference it for us, right? The other two faces that are congruent. What you really would say is there's 3 sets of congruent faces, right? And the third set of congruent faces would be the quote front and back. And could somebody tell me what those are?
7.4 times 3.1.
7.4 times 3.1. And also process of elimination. It's the other measures I haven't used, right? All right. Now, taking that, will you use a side calculator and give me, here's what you can give me. Either give me the whole surface area and put SA and give me the whole thing, or give me the total surface area of the front, back, or the top, bottom, or the sides. So you can give me one of those 4 choices. Give me one set of the parallel faces or another set of parallel or the other, or give me the whole surface area. So you can pick which thing you want to send me. And let me go over here and let somebody in. All right. So just, and tell me which thing you're giving me. Tell me, are you giving me the top, bottom, or you give me the sides, or you give me the front, back, or you give me the whole surface area? So you can decide which you want to do. Let me let some people in that got kicked out. Got a couple Zoom people fall out. Michaela's doing the whole thing. Thank you, Michaela. So did Kylie as their choice. Looks like Pramita is doing that too. Okay, so Jayla, you're saying the side pieces together is 31 square centimeters? All right. Oh, by the way, if I wanted to take this net and get its volume, could I do that from the net? Of course, yeah. You just have to get it back into the construct of what it looks like put together. For example, it would need to be like this. Put this net back into the thing that it actually is, right? I remember when I was a kid and learned how to do this right here, I just thought I was fly. Y'all get that old school terminology there? Okay, so you would just put it together like this, and then you would literally go over here and say, okay, well, this is this much times this much, and then it is this tall, right? And then you just put all that together. So you'd say the base is this times this, and it's this tall, that's the volume, right? If I wanted to get the volume, right? Okay. And so 31 for the sides. Front and back, Jayla, you're saying the front and back is 45.88 square centimeters total? Okay.
Yes.
And then top and bottom. Josie, did you do top bottom? Let's see, is that top bottom? I'm trying to find a top and bottom one that's separate. Oh, here. Jayla, you also did the top and bottom. You said that was 74?
Mhm.
All right. Is Kimani in there? Because his thing keeps popping that he's back in the waiting room. Kimani, are you back in? I can't see if he is or not. All right. All right. So somebody who did the entire surface area, would you be willing, Pramita or Michaela or Kylie, Betty, somebody who did the whole thing? There were some more that did too. Could you just quickly walk us through what the total surface area of this would have been? By the way, if you'd have had TCAP, this is how they would have done that. They would have given you this. I'm just proposing something like this and say, okay, what's its volume, what's its surface area, and have you put it all together like that in a multiple step deal like that. That's the kind of thing they would do on there. Somebody, Eli, your hand's up. Did you know that? Did you want to say something? Our future Meg student there? No? One of those surface area people, do you care to tell us how you got the total surface area?
I will.
Thank you.
Okay, so the top and the bottom, the total was 74.
Okay, yep.
So you multiplied 7.4 times 5, and then 2, and the total was 74. And then the side was 3.14 times 5, and that times 2, which was 31. And then 7.4 times 3.1 multiplied times 2 is 22.94. And then I added that all together and got 127.94.
So 127 and 94 hundredths square centimeters. Like that, right? And I didn't finish up there, but yeah, okay. So I'm gonna, let me move to the next slide. I think it's gonna be, yeah. All right, so moving on here. So we're gonna now talk about this net. So this is the net of a triangular pyramid, prism. Can you tell me where is the base and top of this triangular pyramid prism? Sorry, if you will go ahead and type that, draw that with color coding on the screen. So let me repeat what I just said. Okay, this net, will you color code the top and the base say blue, and the walls red. So give me the walls in red and give me the base and top in blue.
What are we putting in red?
The red is the wall and the base is blue, base and top. Now remember, guys, it is a prism, which means it has a base and a top that match, and it has rectangles for walls. Is this popping up here just a glitch, or somebody doing that? That little thing there.
Is it good?
Mr. P,
Yes.
since it's kind of like an actual triangular prism, doesn't it, wait, hold on. Doesn't it like not exactly have a top, but like kind of like the pointed edge?
That's a pyramid. This is a prism. So Betty, that's exactly why I gave you this one, because you've got to, in your mind, move it around. And several of you are doing that right now. You're realizing I need to move it. But if you look at it like that and you bring it together, it's gonna look like a tent, right?
Yes.
But Betty, is a tent, when it sits on the ground, is it really sitting on its actual true base? Because everybody agreed that makes a tent, right? That's a tent. But is a tent really sitting on its base, or is it actually lying on its side? Betty.
It's lying on its.
Go ahead, Graham.
Oh, it's lying on its side because it really, since it's laying on one of the rectangles, it doesn't truly have a base.
Okay, so let's remember this. If it's a prism, that means it has to have a congruent top and bottom base.
Yep.
Okay? And it has rectangle walls.
Yes, and it's lying on one of those.
So that literal net right there, if I put it together, it's lying on its side.
Correct.
It needs to actually lie on or lay on this right here. So this is a base and this is a top. All right. And these are the three walls. Okay, so check your drawing and see if you were able to, in your mind, move that around. See, I purposely wanted you to think about this one because it's not, because just because it's a prism doesn't mean it has to rest on its base or top. It can rest on one of its sides, but it's still a prism based on its, pardon the pun, its base and matching congruent top. All right?
Wasn't this the math ed puzzle for today?
Yes, correct. That's right. Thank you, Jayla, for making that connection. That's right. Okay, moving on to the next one, which I think will probably be the last one because we're running low. All right, so on here, let me mouse over here to this. Is this a draw or a type? Type. Okay, type. All right, yeah, I want it to be a type. Okay, so taking this, let me give you some information, and then I want its surface area, and that's where we'll stop for today, okay? So it has a triangular base.
Can't pay any money for this.
Okay, if you're on mute, if you're not on mute, if you'll mute yourself. Its base is a triangle, correct? And what is the actual dimensions of the triangle? The triangle, do we know the actual sides of the triangle? No. We
Doesn't
know
say-
the triangle is 5 times 4 tall, right? Correct? So we need that. Okay, so we need, here's what we need. We need 1/2 5 times 4. And we need 2 of those, right? All right, what else do we need to know? It has 3 sides, correct? That are rectangles. And do they all have the same measure? Yes, they do. Now, they happen to have the same measure, which is great. And by the way, we do know what these other 2 sides of the triangle are. They're 5 because that will connect right there, right? And this will connect right here. All right, so we do know the 3 sides. Tomorrow, we're going to do a triangle where the 3 rectangles aren't going to all be the same. You know, like if you had a right triangle, it wouldn't be the same, all the 3 sides of the tent. So this would be a tent as well. So the 3 sides, I would need to multiply 10 times 5. And I need 3 of those. Okay, go ahead and give me the surface area of that triangular prism. And I will just say this because we will.
I cannot look at anybody if I want.
We'll stop on this. Join back in a minute and we'll do Kahoot. I'll send out the stuff for that after we close out of here. But as soon as if you've sent me this, you're good for today. Don't forget to go in and finish your assignments on Google Classroom. And don't forget your Newzilla article on the Earth Day 50th anniversary today to read that. It's kind of interesting. Let's see. Who would like to share how they got the surface area for this? Let's put it in.
I can.
Thank you.
So 5 times 4 is 20. 20 divided by 2 is 10. So that's the area of one of the triangles, and there's 2 of them. So that makes it 20. And each of the rectangles are 50. 50 times 3 is 150. And so you add those up to get the surface area, which is 170 square centimeters.
Square centimeters. Correct. 170 square centimeters would be the total thing. All right, questions about where we are on this? We will do a little more triangular prisms tomorrow with nets, and then we will move on into trapezoidal prism surface area. Anybody got anything they need help with? Don't forget,